All right, so I guess we are on. Welcome, everyone. My name is Laurent Bugnion. I work for Microsoft as a senior cloud developer advocate. And so today we are going to talk about Azure Functions and Xamarin, and I'm going to show you, first of all, an introduction to Azure Functions, to serverless, explain a little bit why it's called serverless and how Azure Functions implement that concept. We have actually quite a lot of demos, so we'll just go through a few slides in the beginning, about like 10 minutes of slides, not even that. And then after that, it will be quite a lot of demos. You have the possibility to ask questions. René, who is also on the line, is going to filter the questions and pass them to me from time to time. And I also have pretty much open end tonight. It's 6 p.m. here, so I didn't book anything tonight. So if you want to stay longer and chit chat, that's fine by me as well. We have about an hour time for the presentation. Like I said, I have a lot of material, and so if we have a lot of questions, we'll just change the course a little bit, but that should be fine. Cool. So let's talk about Azure Functions. So the topic here is serverless code. And what is really serverless? It's kind of a concept which is very trendy at the moment. A lot of people are talking about serverless. A lot of people are trying to implement serverless. It's one of those buzzwords that you hear a lot, like microservices and these kind of things. And so really, serverless, there is, of course, an old joke, which is, why do you call it serverless? There is actually a server. In fact, there are a lot of servers. And so when I asked Microsoft about, when I joined, then I asked the functions team, so why is it called serverless? They say, well, it's not really serverless. It's more like less servers. And so you do have less servers, which means that in your head, you really have less infrastructure headaches. What it means that the servers are still there, absolutely, but you as a developer, you don't have to manage them. And so you're basically cutting off a lot of worries from your world, because those servers are going to be there. They are going to be running. You're not going to have to worry about them if they get broken or whatever. We are going to just swap them for you. And most importantly, we are going to also auto scale. What it means is that if you start up with a small company, and then you have maybe just a few customers, you need maybe just a few instances of your functions application running. But then if suddenly you have a promotion, or maybe you have, I don't know, the holidays are coming and everybody is coming to your store, you don't need to, scale manually your application and buy more servers or buy more instances of the app service. Instead, this is just going to auto scale on demand. And then when you have less people again, then it's going to go down again. And so this is really a nice way to remove that worry from your life. Now, another feature of functions, which is really interesting, is that if you design them properly, if you architect them properly, they can be very cheap to run, because we are going to build you only for the times that the function is running. And so those functions, they don't run for a lot of time, okay? So you're trying to design them in a nice way. You try to avoid a lot of heavy asynchronous operations. Those are all things that you can do in the background, in preparation, etc. But the time that the function itself is running is going to be built, and that's going to be probably fractions of a penny by run, and so that can turn out to be very cheap. Now, if you want to know a little bit more about the name serverless and where it comes from, there is a really funny article here by Paul Johnston, who is an AWS engineer, and he was kind of part of the whole beginning of serverless movement. He's also the co-founder of the so-called JeffConf, which has changed name now. It's called Serverless Conf. I regret that a little bit, because really serverless is just a name, and they could have called it Jeff. And so that's a kind of a funny article to go and read. Okay, so when we talk about serverless architecture, basically what you need to understand, again, we talk about the microservice architecture, buzzword, okay, small units of computation. And so those functions, those lambdas, or those whatever you want to call them, they should be small. They should be pretty isolated from each other. They can, of course, communicate with each other in a way, but the function itself is going to be probably stateless, independent. Now, for those of you who are as old as I am, you may remember the time when we tried to design web applications to be stateless. And so we go a little bit back to that, okay? It's a cycle. And so you try to get those functions stateless. Now, of course, the function is going to gain some state from somewhere. For the computation, it could be if it's an HTTP trigger, for example, meaning an HTTP function. We'll define those terms a little bit later. Then, of course, the state could be contained into the HTTP request, or maybe you have a function which is started when you upload a blob, a binary large object to storage, to Azure storage. And then in that case, maybe the blob itself is going to contain some state. Maybe it can be an image with some geographical information, these kind of things. You have all kinds of ways to start the function, and so for every function, the state is going to be a little bit different. But basically, the scenario, if you want, is that the function is going to be triggered, is going to start up, it's going to do some computation, and then it's going to go back to sleep after saving, of course, the processed state somewhere else or passing it to another service. Now, in function, in Azure, we have quite a lot of messaging possibilities. So we have something called Event Grid, which is a way basically to communicate between the different Azure services. We have connectors. If we have time, we'll see a demo of Logic Application, which is a cool example showing you how to use connectors to create an application which can then trigger a function, for example. And for the function itself, we have what we call triggers. And so, like the name shows, a trigger is what is going to start the execution of the function. And we have quite a lot of those. I already mentioned HTTP trigger. We'll see more of that in a moment. I already mentioned blob triggers, but we also have some things like timer trigger. For example, if you want to have a recurring function, something which happens every 5 minutes, every hour, or for example, every Friday night, at 11 p.m., for example, if you want to run some reports, etc., etc. Now, one cool thing with you know, the Azure functions, so the Microsoft implementation of the functions, is that you have, as always, I would say you have a really nice tool chains, and so we support Visual Studio for Windows, of course, but you can also develop them on Visual Studio for Mac, or we also have Visual Studio Code, which is an open source tool that you can use on, it's also cross-platform, and so you can use it on Linux, for example, on Mac or on Windows. It's a lightweight tool that people love to use. Pretty much, it's very popular, and that allows you to write functions in a very, very simple manner and very fast manner. Now, we are going to talk a little bit more explicitly about APIs. So how can you use functions to build APIs? And so in that case, you're probably going to choose HTTP triggers, which means that the function is going to react to an HTTP request. And this request can be a post, a put, a get, a delete maybe, well, why not? It might make sense. Very often we have, of course, get and post. And so this is what we are going to use. And what you're going to do is probably have one function per API endpoint. Like this, you have a nice separation. And for example, if you do a calculator, you might have one function for the addition, one function for the subtraction, one function for the division, etc., etc. And of course, this creates maybe a little bit of clutter, or at least you might think this way, because since you're going to have you know, multiple URLs, multiple HTTP endpoints for each function. And so what thing you can do, you can easily hide this complexity. For example, we have something called proxies. And so those proxies allow you to say, okay, I have one URL with parameters, and then depending on the parameters, I'm going to start function A, function B, or function C. And of course, the complexity like that is hidden from the user. The user only sees a proxy as a URL, and he doesn't see the architecture which is behind. It's a very nice way also to keep evolving your functions. For example, you can easily add or remove some functions, and the user doesn't need to change anything. Another thing worth mentioning is that functions are very easy to secure, and so I'll show you a little bit later in the advanced section how you can, for example, set some SSL certificates on your function in order to support HTTPS. You can also have some authentication providers, and here too we'll see a little bit how it works. And so, for example, out of the box, we support, of course, Azure Active Directory, the Microsoft way to authenticate, but we also support things like Google or Twitter or Facebook. And so if your users have this type of account, you can easily log them in and make sure in a very transparent manner. So you, of course, your function doesn't get the login credentials or anything, but Twitter will give you a token and say, yes, that person has been authenticated, which is really nice. Okay, so we are going to start with a demo, and I'm going to show you here how you can build a function. And so the first function we are going to build, we are going to go into here the portal, the Azure portal. This is where you handle basically all your properties, I would say, all your resources that you have in Azure. And one thing you can do is create functions, including code, into the portal. I don't necessarily recommend that for production, but it's a great way to get started with function and to understand a little bit how they work. So when you want to create a new resource, you go here, you click on create a resource, and then after that, you're going to have to answer a few questions. So first of all, let's select here serverless function application. And I want to underline that for each of those topics here, we have quick start tutorials. I'll give you some links at the end of the presentation, but you really have the possibility to very, very quickly, in 5 minutes, more or less, to learn how to get started. So that's really nice. Let's create a serverless function application. And then we are going, of course, to fill a few information. So, of course, we need a name for the application. The application is going to run at azurewebsites.net. So it's going to be your function name .azurewebsites.net. Of course, if you don't like this name, you can also very easily buy a domain name and assign that domain name to your functions application. That works. Then you're going to have here a subscription. This is where you're going to be billed for those fraction of a penny that I mentioned before. And then you're going to have a resource group. And so the resource group is where everything is going to be saved. For example, you might have the function application itself, but maybe you're going to have also a database, or maybe some blob storage, or maybe some, well, I don't know. I mean, any type of services that you want to use. So you can have everything in one neat location. And like this, if you want to delete everything, for example, it's very easy to find it. Now, in terms of the operating system, I want to mention that we support Windows, of course. So the server is going to run on Windows, the famous serverless server. And then we'll have, of course, Linux is also supported. And so for Linux, we are using ASP.NET Core in the backend. This is still in preview, and at some point it's going to get out of preview. At the moment, you can already start using it, start implementing everything. And so if you develop your application with ASP.NET Core, you have, of course, the possibility to have a fully cross-platform application, which is going to run on Windows, on Linux, or on Mac in the exact same manner. Docker is also an option, and so that means that you're going to deploy to a container, and then after that, this container can be basically saved and can be reused in multiple places. So you have a very well-known environment. It's, of course, containerization, which can be interesting. For example, if you go to production and you decide, okay, I'm going to publish to a container like this is a well-known environment, I would say. Okay, let's talk about hosting plan. And so here, as you see by default, it's consumption plan. What it means is that you're going to be billed as you consume your function, as you use them. And so for the rest of the time, when the function is not used, it's going to sleep. So that's the model I was mentioning before. Now, at some point, you might have an issue because maybe suddenly you have a lot of users, and maybe you want to know exactly how much you're going to be billed per month. And of course, it's hard to budget if you don't know when your functions are going to run. So you also have the possibility to switch to something called app service plan. The name is not great, but basically what it means is that you'll have what we call an app service, a web application that you create in the Azure portal, and you're going to host your function in this web application. And so when you do that, you're going to know exactly how much you're going to pay every month, depending on the bandwidth, depending on the RAM that you want, depending on the number of cores, the size of the storage, these kind of things. And so that can be useful, especially for later, if your application is really taking off and you want to know exactly how much you will pay. Now, one thing I need to mention is that you can host multiple web applications per app service plan. And so if you have an app service plan with already a web application running on Azure, well, you can take your functions application and put it in the same app service plan. And basically, you can continue to add things until your service plan is maxed out, in which case you might have to upgrade to the next service plan. Okay, location, we do have quite a lot of locations where we support Azure Functions. As you can see, in my case, I'm in Switzerland. I would choose Western Europe, which is closest from me, and it's really just a matter of reacting faster. We are bound by the speed of light, and so choosing a location which is close to your users is a good idea. And then after that, storage. Not every function needs storage, but if you do need storage, you can create a storage account with a better name than that. And then after that, you can use it to store your data. Now, Application Insight is turned on by default, and this is where you will have all your analytics. And so it's a very, very powerful service. You can know you can get a lot of information on your users, where they are located, what language they speak, etc., etc., and that can help you tailor your application depending on the usage. We also, of course, support crashes, reports, and we support deep analytics. You can turn it off if you don't want to. If you turn it off, you still have basic logs that you can use. At this point, we would create the application, but I did that already, and so I'm just going to discard my changes, go back to my functions applications. And here I have already this function application created. You may notice that it is empty at the moment. I don't have any functions. And so we can go and create one. So let's do that. I'm going to click on create. And here I have a few templates which are already predefined if you want. But if you want, you can also create your custom function. And here you will have the possibility to select the trigger. So I did already mention HTTP trigger. I did mention timer trigger. One thing I want to show you is that we also support multi-language for functions, and so out of the box, totally supported C#, F#, JavaScript. But if you go here in the top right corner and enable experimental language, you can even write your function application in Batch, in PowerShell, in TypeScript, etc., etc. We even support more languages than that. Actually, you can write functions in Java, etc. So let's go back here and let's continue to review those triggers. So here, for example, we have the blob trigger I mentioned before. This is great if you want to upload an image and then, for example, use the function to perform some image recognition. Why not? Using custom vision. We have Cosmos DB trigger if your collection is changing. We have IoT hub if you want to have, for example, a building with an IoT hub and then you want to have a function running every time that something changes. Maybe it's maybe you want to run reports, or maybe you want to optimize, for example, the air production for the house or things like that. You can have some webhooks. Like one interesting webhook is a GitHub webhook, and so you have a possibility to run a function, for example, every time somebody commits to a specific branch, etc. Then we have all the HTTP, and let's take here an HTTP trigger with parameter. I'm going to choose that in C#. And I'm going to say, okay, let's call that say hello for the example. I'm going to set the authorization level to anonymous because I just want anybody to be able to use this function here. And then I'm going to create. And so that's going to create the function itself. It's also going to create all the connectors that are needed. And here it's going to put some code directly in the web browser. So let's take a look at what we have here. So we have the request, which is coming, which is going to contain some state. And then we have this name parameter here. And so where does this name parameter come from? So let's go here to the integrate tab. And here you have quite a lot of information. So you can select some inputs and some outputs. But really the thing which is interesting is that you have the root down there. And so this root is a part of the URL. And so in our case, we're going to say hello. So this is going to be kind of the name of the function that we want to trigger. And then you are going to have the name parameter. And then you have the value of the name parameter with those curly brackets. And so you could have multiple parameters like we will see later. And here you can also select which HTTP methods this function is going to support. And later I'll show you how you can have how you can differentiate, for example, with one URL and multiple HTTP methods. But for now, let's keep it this way. I'm going to save that. And then if I go back to my code, you will see, of course, the name parameter, which is going to be extracted from the URL by the Azure Functions runtime. And so now we can write some code. So you see it's going to create a response using HTTP status OK. And so that's code 200. And then it's going to say hello, and so we can modify that directly in the web browser, which again, as I said, it's not the the best way to do some production code, but it can be useful to test things out. And now if I save my function, basically it's running already because it is serverless. So it's already taken care of. It is running somewhere and I don't have to worry about that. The only thing that is interesting for me, since it's an HTTP trigger application, I want to get the function URL. Let's copy that. I'm going to copy it from here. And then if I go and start here a web browser, we are going to see, I don't really want to zoom in because I'm afraid to break here the transmission, but basically we have hello, which is the root that I defined. We have the name parameter, and then I can enter a value for this name, for example, Laurent, which is my name, press OK, and after a short wait, we see hello Xamarin Uni Laurent, which is exactly what I did. So basically my function is already up and running. This XML has been added by Edge. It's just to help me debug, but basically what is transmitted over the wire is just this string. And so since we are transmitting a string now, which is of course HTTP, okay, Hypertext Transfer Protocol, well, we could also of course transmit some HTML, some XAML, some XML. Well, you could transmit some XAML if you want. I don't think it makes a lot of sense in that context. You could transmit XML. You can of course also transmit JSON, which is really what we do most often. All right, so now we have a small example of function running. That's cool. And here you can even go here in the test tab, and then you can run some tests here. So you can say, okay, let's change the values of the parameter, change some headers, for example. But again, at some point you kind of hit a wall and it's a little bit too complicated to test in the web browser. And so of course you would prefer to go in Visual Studio. So let's do that. I'm going to just go into an empty Visual Studio, and I'm going to create a new project from here. And so this is going to ask me what I want to do. And so I have here the cloud workload, and here I have Azure Functions. So same thing as before, we are going to create the function, and here I'm going to make a calculator. Let's say OK. And so it's going to create a function application. Now it's going to ask me what trigger do I want. And here you see I'm using Azure Functions v2. So it's .NET Standard, which means that I will be able to deploy that function application to Linux if I want to. Or of course on Windows, as you would expect. I'm going to take an HTTP trigger again. I don't need any storage here. And then let's set here anonymous function, anonymous access rights again. If you choose functions, it's just going to add a code to the query string, and it's a little bit better if you want to avoid bots, for example, and these kind of things, as long as you keep the code anonymous. It's not protected in any manner. Otherwise than that, it's still HTTP, but at least you're going to be a little bit less exposed, I would say. But here I'm just opening to everyone for the demo. And so it's going to create the functions application. It's going to create one function, which is the one I just selected now, so the HTTP trigger. And as soon as Visual Studio is done working, which I hope will happen soon, here we go. Now we have the code, and so let me zoom in a little bit. And so it's a function, it's an application really pretty much like any other, okay? It's going to just refresh the NuGet packages, so it's going to just take a second for the IntelliSense to appear. But in the meantime, we can already start working. And so for example, I'm going to create here the add endpoint for my calculator. And then I'm going to configure this function. So you remember before I went to the integrate tab. Now here I'm going to do the same thing. Those squigglies are going to disappear in a second. I'm going to do the same thing with this HTTP trigger attribute. So for each type of trigger, you have an attribute that you can set at the run method level, and then that's going to help you configure everything. So here I have authorization level anonymous. Then I have the methods, and so I probably here want only get for this method, so I'm going to remove post, okay? And then I'm going to specify the root. And so again, the root is part of the URL, just like before. So let's say this is going to be the add endpoint. And then I'm going to have the first number and the value of the first number. And then I'm going to have the second number, and then again, the value of the second number. Okay, then I'm going to have here the HTTP request to which HTTP trigger was applied. And then I have the log. Now, how do I access the value of num1 and num2? Well, very, very conveniently, you can just add them to your signature here. And so I'm going to go even further. I'm going to define them as integer, which means that the Azure runtime is going to take those strings from the URL, attempt to convert them to an int, and give them to me. And if it's not working, it's handling the errors and notifying the user. Okay, so now let's build the function. So I'm going to remove here the predefined code. I'm going to add here something. And so here we are going to say, okay, let's create a new addition result. Oh, we don't have that object. That's fine. I'm going to create it now. Apparently, IntelliSense is a little bit slow now, so I'm just going to add this. And then let's go and try to create this class in a new file. Okay. And so what I did in this class, I added the result, which is a result of the addition, and then I added the time on the server, because why not? It's just because I wanted to have two properties. And so if I go and visit this class, you see I have my two properties here, like you would expect. So this is a C# object. It's an entity, if you want. And now the cool thing is that my entity is going to be serialized because I pass it to this OK object result. It's going to return HTTP code 200 to the caller, and then it is going to serialize the result to JSON automatically. Why JSON? It's the default. I could also serialize it to XML or something else if I wanted to. But of course, in that case, JSON makes sense for our mobile API if you want. Okay, so now is a really, really cool part. I can test this application directly locally here on my machine. So I don't need to deploy anything to do the test. So I could write also some unit tests, of course, if I wanted to. But here I'm just going to start in debug mode. And so it's going to spin up the Azure runtime, the Azure Functions runtime. And that's exactly the same runtime that you have on Azure in the web portal. So it means that basically if it runs on your machine, you're going to be quite sure that it's also going to run in Azure in the cloud. So after a short while, you will see the command line console, which is starting up. And then it's going to show you a very, very nice ASCII art in a second. It's just a little bit slow, probably because of the transmission, but here we go. All right. And then after that, you're going to get information about what you need to do, what you need to call to debug this functions application. And so at the end of the console, you're going to see a URL. Okay, it is indeed quite slow. Here we go. And now if I take this URL here and go into another web browser, okay, you will notice that it is running at localhost. And then I have the route that I defined. So I have add, then num1, and then I can enter my number, for example, 12, and then I will enter another number. Let's just verify that we have a breakpoint. Yes, we do. And then I'm going to press enter, and then it's going to jump in Visual Studio in debug mode, and it's going to allow me to execute step by step. If Visual Studio wants to wake up, here we go. And so now I can execute step by step. And of course, it's also going to allow me to inspect everything like you would expect. So I can inspect my result. The result is 42, which is of course correct because it's the answer to life, the universe, and everything. And I can execute. And now if we go back to our web browser, we see that we get the result as JSON, just as you would expect. So now that's pretty cool, but how do we actually publish that? How do we consume that in a Xamarin application, for example? So of course, you could consume that in any application you want. In our case, we are in the Xamarin University, so let's do Xamarin. So the first thing you would do is publish this. And to publish, I really recommend, people know that it's kind of a running joke in our team, but we really recommend having some nice continuous integration, continuous deployment pipeline. So you will have some scripts in PowerShell or in any language you want, deploying this to Azure, making sure that everything's working. Now, if you're just testing things out, you can actually deploy directly from Visual Studio. And so if I open here the Solution Explorer, you can right-click and publish, which is not something you want to do in production. And then you will have the possibility to select where you want to publish your Azure application. And so here you can either create a new one, which is going to show you pretty much the same questions that I showed you in the very beginning of this presentation, or you can go and select an existing function application. And for example, if I do that, it's going to connect to my subscription. It's going to take a moment to refresh everything. And then it's going to show me all my already created functions application. And I can select one and say, I want you to publish there. So that's pretty convenient. And for example, here we go. We have well, I don't know really. We have, for example, LB quick test, which I could go and select to publish to that. So that's quite convenient. Now, in that case, to avoid losing time, I actually already published this function. So it is called here LB calculator. And now if I go and see what I have my add function. Okay, this is one I just created for you. And here we see that we don't have code anymore because this function is called read only. Sorry, what it means is that it is basically created externally in Visual Studios and it is published to the portal. And so it doesn't make any sense to write some code in that configuration, but you can still, however, get the URL, of course. And so that would be the endpoint of my function. So let's copy that. Or you see that this one actually has the code that I mentioned before. And so what it means is that the authorization rights have been set to function in that case. So if you keep that code confidential, you kind of avoid having too many bots hitting your application. So here I'm just going to copy that. And now let's do a little bit of Xamarin. So you are all, of course, Xamarin experts by now, I guess. And so you recognize here a Xamarin.Forms application. Don't worry, we'll keep it very, very simple. This is an application which is actually already running offline. And so here we have Android, iOS, UWP, and we have some XAML. This XAML is going to be rendered to Android, to iOS, to UWP. We have 2 entries for the 2 numbers. We have a button, and then we have a label for the result. Now in the code behind, we have here the clicked event handler for the button. And as you see, I'm doing here the calculation offline. So where is the fun in that? We're going to do the most inefficient thing ever. We are going to take this very, very simple operation to the cloud. Again, it's just an example. But basically what I need here to call my function, I will need my URL. Okay, so here we go. And the URL is the one that I just copied before. And so here you see again, you can recognize the root that we mentioned before with those placeholders for the first and the second number. So that's cool.
Laurent?
Then after that, yes, go ahead.
So we've got a question here. What would it take to now, you mentioned these Azure function proxies before. What would it take to place them in front of that URL that you have just generated?
Yes, that's a great question. And so basically this whole configuration happens in the web portal. So here down there, you see this is my application that I have, okay? I wanted actually to show that as part of the advanced section, but we can show that now. And so here we have proxies, and we have the possibility to create one or multiple proxies. So if I do create one proxy here, you will have to enter a few information, for example, the root template. And so you're going to say, okay, this proxy is going to respond to this URL, okay? And of course, the root template is independent from my domain name, right? So here my domain name is lbcalculator.azurewebsites.net. But if I decided to add a custom domain to that and have, for example, as you know, as some of you know, most of my stuff runs at Galasoft, for example, I could have, I don't know, a subdomain called calculator.galasoft.ch and then assign that custom domain name there. Then the root template I can define. I can say, okay, this proxy is going to act only for get or maybe for get and post or whatever. And then you're going to say, okay, at the end, we are going to redirect that, redirect that request to that specific function, okay? So this is how you will define that. Now you have other ways to work as well, and you have also the possibility to define, if I go back to my function here into the integrate tab, you also have the possibility to work at the template level. I'll show you an example in a moment. So basically to say, okay, if I have the same URL twice, but I have in one case it's a get and in another case it's a post, you can say, okay, I will have actually 2 different functions. One is handling the get and one is handling the post, but the URL is the same URL. I'll show you that a little bit later, okay?
All right, thank you, great.
No, absolutely, no problem. Okay, so we were back here. So we have this URL, like I said, and again, I understand the question because this URL is pretty ugly, right? So you might want to beautify that. That makes sense. But again, don't forget that it's an API, right? So the beauty of the API is a little bit less relevant in that case, but you could totally change that and make that a lot nicer. Okay, then we will need an HTTP client because we are doing HTTP work. So let's create here an HTTP client. I'm just creating it as a singleton here. Of course, you might know that it's not the most efficient way to do things. And then after that, we are going to create here a try catch. So I'm going to disable the button just for a better user experience. I'm going to catch exceptions in case there is one. There might be one if I don't know, if there is no internet connection, for example, or if the server is too slow to reply, which of course on Azure shouldn't happen, but you never know. And then you are going to take this URL. We are going to replace this placeholder with the first number, the second placeholder with the second number. We are going to get the JSON using the HTTP client. And then we are going to use JSON.NET to convert that. Now, in that case, I actually didn't add JSON.NET yet. So let's go in NuGet, and I'm just going to say manage NuGet packages. I can browse, and of course, JSON.NET is the very first one in the browse tab because it's the most popular by far. And this is what we do. We all bow to James Newton King. And by the way, you might have heard that James recently joined Microsoft. And so we are very, very happy to have him on board. It's really a great addition to our teams. And so once we have NuGet doing his magic, we can go back. And of course, after that, you know the drill. We are going to deserialize the JSON. The object that we deserialize to, let me add the namespace now. Okay, are we done now? Almost. Voila, so now we know newtonsoft.json.net, okay? And then after that, we deserialize to this object, which is the addition result, which is the entity that I created on the server. Now, the beauty here is that since we are using .NET and C# in both cases on the server and in the application, we can, of course, take this addition result entity directly in the application. So in a real life scenario, I would create, of course, a class library here. I would probably do it in .NET Standard, but in that case, I can simply go and take this item. I'm going to take the class directly from my repository. Let's take the calculator, and this is the addition result. And one thing I can do here is add it as a link. So basically, I'm not going to copy the physical file, but I'm just going to include it into my application. And this is the exact same file that we saw just before. So like this, the deserialization from JSON is going to work. And then after that, I can go ahead and show the result. For example, let's remove that and say, we're just going to take the result and set that to string. So at this point, this application would work. So we have, I already actually built it and deployed it. So I'm going to show you, here I have the Windows version. And then after that, we'll try to mirror my phone and show the Android version as well. Not sure. Oh yeah, actually it's here. Okay, so now we have the client. Okay, you see that my UI skills are absolutely beautiful here. I'm going to click on please wait, and here is the result. Now let me try to mirror my phone so that you can see the Android result, just to prove to you that it is actually working. Okay, I'm going to start Visor, which is basically mirroring tool. It's taking a second to start, or a little bit more than a second. Oh no, here it is. Okay. And apparently it has a problem with my device. Let me see if I can do that again. It seems to be showing it offline. Yeah, okay. I had that problem before already. I seem to have some issue with my phone, but basically you can believe me, right? The application is working, and I can share screenshots if you want later. And so we have basically everything running. I could also running on iOS as well, very, very easily. Okay, so that's kind of a small, complete example if you want. Now, of course, at this point, you only have choice to do whatever you want with that. You can build some way more complicated applications in the back end. But instead of doing that, why don't I show you some examples which are a little bit more advanced, and hopefully you're going to be able to learn from that. And again, don't worry about the repos and everything. You're going to get all of that at the end of the presentation. So here I have another application. I call it Coin Client. And so what does it do? It's basically an application which is going to help me observe the value of Bitcoin and Ethereum. And so here you see the Windows version of this application, okay? And so if I click refresh, it's going to hit a function. And it's going to give me the current value of Bitcoin and Ethereum, but it's also going to give me a trend. And so this trend is going to be calculated over the 10 past hours. So how do I do that? Again, I apologize for the slowness of everything here. It seems to be how do you say, the GoToMeeting connection is slowing my machine down. It's kind of a known problem with this machine. Anyway, so now we see that Bitcoin is going up, Ethereum is going up. We are all going to get rich. We are all very happy about that. And so how do I calculate the trend? Well, basically, I have two functions. So here is my function application in Visual Studio. And here I have the client. So you see I have a game client for Android, UWP, and iOS. And so here I have two functions. The first function is called the coin value saver. And so the saver is going to be a trigger, a timer trigger. So before I mentioned the HTTP trigger, now we have a timer trigger. And what this expression means, it's a so-called cron expression. So it's cron is not a Microsoft concept, okay? It's something that everybody is using to define some schedulers. And so here what we say is that basically every second of, when the second is 0 and the minute is 0, every 1 hour on any day, any month, any year, I want this function to run. So this function is going to run automatically every hour, okay? And so the rest is just code. I'm not going into the detail too much, but basically I'm creating a cloud storage account, and then I'm creating the table client. So I'm using here something called Azure Tables to store my data, okay? And this Azure Table is a very, very easy way to do database on Azure. Now, if you want to upgrade to something much more powerful, you can use, for example, Cosmos DB, or we have SQL Server, etc. But Azure Tables to get started is really cool. And then I'm going to hit a service here. This service is a third-party service. It's CoinMarketCap. It's going to give me some JSON. I'm going to deserialize the JSON here, and then I'm going to get the value, and then I'm going to save this value here into the table. And so I do that once for Bitcoin. I have another entity here for Ethereum, and so I have my table with Bitcoin and Ethereum every hour. Now, one thing which is really cool is that since this function is going to run independently every hour on Azure, I can also go in App Center.ms, and I don't know if you're familiar with App Center. If you're not, you want to check it out. It's really cool. It's a nice way to do some really nice things for your mobile applications. For example, you can do some continuous integration. So you can basically build your application for Android, for iOS directly in the cloud every time that you commit to GitHub to a certain branch, for example. We have a bunch of things. We have, let's take, for example, here the Android version of the application. So this is a build. You can test your application using under the cover Xamarin Test Cloud. I'm not going into the details here, but basically you can run your application on physical devices who are located in Denmark in a container. You can even actuate the buttons like camera buttons or stuff like that. It's really pretty awesome. I think there are some courses about that in the Xamarin University, so check it out. You can distribute your application to beta testers. You can do some diagnostics, so basically some analytics. And here we have push. So we have push notifications. And here you see all the notifications that were sent. Notice that those notifications were sent pretty much every hour, okay? That should remind you of something. And so basically what I did is that in my code, I added some code which is going to send a notification through App Center directly to my devices, and I'm going to send every hour the value of Bitcoin and the value of Ethereum. And like this, on all my devices, on my Android, iOS, and Windows devices, I'm going to get a notification every hour telling me, oh, okay, you know, the value is going up, the value is going down, maybe you should buy, maybe you should sell, okay? So again, those functions are very, very versatile. Like you see, this one is a timer trigger. So I'm just going to deploy it and not going to worry about it at all anymore. It's just going to run every hour. Of course, we have another function here, which is a trend getter, and this one is an HTTP trigger, like you would expect, using get. And so this one is going to return basically JSON containing the value of the value of Bitcoin and of Ethereum. And I'm also going to get here the 10 last values, and I'm going to run a little bit of a linear regression just to know if it's going up or down or flat. and this is what I'm returning. So this is a cool example. I will let you check it out, and I don't go deeper here because I want to show you more advanced topics. But of course, you'll get a link to the repo at the end. Okay, so in terms of advanced topics, so one thing I can show you, which is really cool, is that if you have, like I told you, right, you can have two functions. And so let's create a new function application here. And you can have two functions which are behind the same URL, okay? And so if you say, for example, I have, I don't know, I have a pictures application, so I will have API/pictures. And let's say that I have a get, a get URL, a get method, HTTP method, so that I can get all the pictures, for example. But maybe you want to have the same URL and you want to post a new picture, you want to save the picture to the service. And so it is really easy to do that using Azure Functions and root templates. So let me just create here with the default names to go a little bit faster. And then we are going to create here, for example, HTTP trigger. I'm not going to need that. I'm going to set that on anonymous as well. So same thing as before. And then we are going to take care of defining. We are going to take care of defining the root template like we did before. But the nice thing here is that I can really define the same template in both cases. And simply playing with the HTTP method, we can direct the code to the correct application. So hopefully it's going to create soon. Here we go. So now we have our, let me put that out of the way. We have our first function here. I'm going to create another function here saying add new item. Okay, I'm going to take, yes, Visual Studio is initializing the templates. Okay, I'm going to take, where is it? Let's just search for hello. Okay, let's just search for Azure. No, I think it's called function. Why don't I see functions here? Where am I now? Okay, that's interesting. Okay, I don't see that. So one thing we can do is that we're just going to take this file, duplicate it. Now, I never tried that, but I think it should work. I'm just going to rename it to function2 here. Okay. And then I'm going to change here. The namespace is fine. I'm going to just change the name of the class. Okay. So now, like I showed you before, we said, okay, we have, so in that case, let's say that this is a post one. So I'm going to say return a new OK object result. And I'm going to just pass this is a post, for example. Okay. And so in order for the post to trigger this function, I'm going to go here. I'm going to define my root template just like I did before. And let's say this is called photos, for example. Oops, photos. Here we go. All right. And so in that case, I say I don't want get, I want post. All right. Now let's copy that. And I'm going to go into the first function. Okay. And I copied everything under here. So I'm going to paste that. Voila. So now I have the same thing as before, except that this time I say this is get, and I'm going to do something else. Okay. And now I can run this application again. And so this time it's going to start. It's going again, just like before, to start the, the Azure Functions runtime. And to testing out, for example, we can take Postman. I don't know if you know Postman, but if you do anything with web APIs, this is an awesome application. It used to be a Chrome application, but now it is actually a desktop application. So it is an independent app that you can install. It's free of use, which is really cool. And you can even go and save your requests. So if you have some requests that you execute very often, you can use that. So we are going to use this to send an HTTP request to the local host. It's going to take a second to start again. I apologize a little bit for the slowness of it all. If you do that without GoToMeeting running, I guarantee you it's really going a lot faster. I can also go and close this. I don't need that anymore. And if at some point things are happening, you will see, so since we have two functions running now, we are going to get two URLs in the command line application, but those URLs are, in both cases, are going to be the same because I defined the same root template for both URLs, okay, like you remember. And then the only difference being that in one case, one function is going to respond to get. And so here you see we have these two URLs. The two URLs are the same, okay, it's the /API/photos. If I take one here, and let's go to Postman. I'm not sure why this is not up yet. And by the way, I can place here my breakpoints already. So I'm going to put a breakpoint here in the get, and I'm going to put a breakpoint in the post as well. Well, the get, we actually don't need Postman to test it. Okay, I can test it directly from here. So if I do that, of course, the web browser is sending a get. That's what you expect from a web browser. So it's going to jump into the get place, which is correct. Okay, so I'm going to execute. This function is still running. Postman is not starting. After Postman is started, I'll just get back to that because I have a few other things to show you. I'll just get back to that to show you how to generate a post request directly from Postman. But basically, if you send a post, then the other function is going to trigger. So you have a really nice way to modularize your request if you want. You can even start, for example, with one big function doing everything and then split it in multiple functions. So using both root templates and proxies, you have really a high level of flexibility, which is really cool. Okay, another thing I really would like to show you is deployment slots. So what is deployment slot? It's probably the best thing since sliced bread for application developers. And so if we go here to this function, this is another function I created. It's just called quick test. You can actually say, okay, every time I publish my application to Azure, I take a risk, okay? So of course you don't want to deploy, you don't want to test in production. I guess that's what I'm trying to say. Okay, you want to deploy something which has been tested quite thoroughly. And so we have unit tests, of course. Then probably at some point you're going to have a test server, maybe a staging server, and then you're going to have the production server. But the really cool thing with slots here is that you can go and create a new slot. So I'm going to say create new. Now, initially it's going to tell you, be careful, please. This is still in preview, and this is because the whole thing is getting optimized. And by the way, you can already use slots in production for web applications and web services. So for functions, it is in preview, but for app services, for web applications, you can already use it, and I use it all the time. So here I'm going to say, yes, I'm aware of the problems. I'm going to create that to enable the slots anyway. Okay, so now this is enabled. And so if I go back, I'm not sure if I need to save. No, I think this is coming automatically, okay? And then if I go back to the slot and create a slot, now it's going to tell me, okay, what name do you want to give? And for example, I can say staging. I'm going to create that. And then what it's going to do is that directly from Visual Studio, before I showed you that you can publish from Visual Studio, okay? So now my slot has been created. And this slot, you see, this is my main slot here where I have all my settings and everything. And here I have another slot where I can use different settings or the same settings if I want. So I can use, for example, another database. I could say, okay, here I'm going to use a staging database to do maybe a last test before I actually push to my server. Now from Visual Studio, you can select, let's go to the calculator, for example. When you start here the publication and you say select existing, if we give it a moment to refresh, we are going to see this LB quick test that I just configured. And underneath the LB quick test in the tree that you will see in a second, here underneath that, you will see that now I can expand it and now I have deployment slot. So instead of deploying to production, I can deploy to staging. Okay, and so the beauty now, which is really awesome. So of course you can also do that, you know, using scripts like I mentioned before. The beauty now is that if I test my staging and everything is running fine, I can super easily go back to my overview and then I can swap the staging and the production. And so it's simply going to do a swap. What it means is that it's going to replace staging by production. It's going to replace production by staging. And so if something goes wrong, and you see that, oh, I have a last-minute bug that I didn't find in my unit test. I didn't find it on the test server. I didn't find it in staging. The test is in production now. Very easily, you can go back here. You can swap again. And like this, you restore to the last known working version. So it is really awesome. Okay, another thing I'd like to show you, I know that I have just 5 minutes, but let me show you that. And then after that, I think we'll maybe break for questions and see how it goes. But basically, another thing you can do is that you can also, like I said, you can very easily authorize or add some authentication to your functions. So we just recently, my good friend and colleague, Jim Bennett and myself, we just recently gave a one-day workshop in Greece at the David conference, and we wrote everything up. You wouldn't believe how much time Jim took to write it up. I verified everything. It works pretty well. And so here, if you go at this URL, I'll give you that a little bit later. You have a full-blown application, which is using Azure Functions. It is using block trigger, HTTP trigger. It is using authentication. You build the Xamarin.Forms application. It is going to use cognitive services to recognize the picture and everything. So here it is very well detailed how you should set your authentication and everything. But let me quickly show you. So if I go, for example, with the, so you can do that with Twitter. You can do that with Facebook, for example. So if I go to developers.facebook.com, this is where you can log into Facebook, and then you can create an application. So if I go and log in, okay, let's just log in. Voila. So if I go and check my apps, you will see here I have this Happy Exam Devs application. Okay, this is the application that we built together in the GitHub that I showed you before. And here you are going to have all kinds of information. And here I'm using the Facebook login as a product, okay? I will have some settings, including some keys, which are interesting because the keys are going to be what you need to copy into your application, okay? So here I have everything that I need to set up. I have the application ID, for example, here. And then after that, if I go on my portal and I say, well, I would like to secure, for example, this application here, I will go under Platform Features. And down there, I have authentication authorization. So I'm just going to click here. Incidentally, it is exactly the same way as we would secure a normal web application, okay? Now, by default, app service authentication is going to be switched off. But if you switch it on, you have the possibility to say, okay, I want, every time that a request comes, I want to log in with Facebook. And then after that, on the Facebook, and you see we have other services. We have Azure Active Directory for Microsoft, services running on Microsoft or serving in enterprise, etc. We have Facebook, Google, Twitter. We have also Microsoft accounts. So if you use, like, for example, a live.com account, an outlook.com account, these kind of things. And if you go to Facebook, you're going to have a few configuration settings to take care of. For example, the app ID and the secret. Now, everybody saw my secret, and so I'm going to reset it, of course, which, by the way, should be like that. You can say the scope that you want to use. In our case, we only need the public profile because we really only need the login information. And then you can say OK, and basically your application is configured. Okay. You still need to define here a callback URL. Again, we define everything in this GitHub, so don't worry about that at the moment. And then the nice thing with that is that you can, after that, go into your Xamarin application. You can say, just going to show you that, you can add a NuGet package, which is here. Okay, you can add a NuGet package, which is called Microsoft.Azure.mobile.client, mobile.client, and this is going to handle the authorization for you. So it's going to take care of creating the web dialog where the user can enter his username and password. It's going to send that to Facebook. Okay, you as an application developer, you never see those credentials. It's going to send that to Facebook. Facebook is going to send back a token saying, yes, this user is authorized. And then your application is going to be allowed to continue. the next request, you're going to save all that. The next request, you have the token already. You don't need to reauthorize. And so you can continue the feature like that. And so you have full control over your authorization flow, but at the same time, you never see a username and password. So it's a nice way to do things. So again, if you go to this URL here, you will see the whole thing there. Okay, so that's pretty much what I wanted to show you. I want to point your attention to another serverless offering that we have on Azure, which is called the Logic apps. And so if you create a Logic application, you're going to have a really nice editor directly in the web browser, and you can create an application without code. Now, I know what you think. I think the same. Without code, oh my God, what kind of sorcery is that? We are going to, probably run out of a job or whatever. Actually, not at all. The nice thing with that is that Logic apps have hundreds of connectors. What is a connector? Well, basically, it is something that is going to trigger the execution of this application. And again, this is all running on Azure. It is serverless, which means that you don't need to configure anything. It is going to auto scale. And so here, for example, I have a connector, which is an Instagram connector, which says when you upload a new media to the Laurent Bugnion account, and check that, please, every 30 seconds, then please connect. Now, this icon is cognitive services. So please use a cognitive service, an Azure artificial intelligence service, to take this URL and to describe the content of the picture. And then for each caption that is generated, please post a tweet to Twitter using the L Bugnion account saying, I see, and then the text of the caption, and then the URL to the Instagram post, and then those tags. And so using this, you can basically configure a whole lot of things. If I add, let's add an action. So just so that you can see all the connectors you have really literally hundreds of connectors. You have things, for example, you can also write an Azure function. By the way, you can say, okay, once this function is executed, please do something in a Logic app, or do something in a Logic app. For example, I get an email from Outlook and then run a function because I want to write some code and I want to execute something a little bit more complex. And so here you see all those actions that you have. You can do really tons of things. You can do some really funny things that you might not expect from a Microsoft service, like, for example, saving something on a Google Drive, or adding something to Google Calendar, or sending a Gmail, okay? You can create issues directly on GitHub. You can do really tons of things. This is also a serverless offering. I'm not going to go deeper here because of lack of time, but please remember that Logic apps are pretty awesome. And so Azure Functions and Logic apps work really hand in hand to create some very, very powerful applications. Okay, so I'm going to just go back to the slides to show you some resources. So the first resource I want to show you is the first example I showed you. There is actually an article about that, and there is also an Azure sample, one of the official Azure sample at this URL. I'll give you the slides in a second. And so this is a step-by-step detailed instruction on how to build an Azure function with the Xamarin client. The workshop that I just mentioned right now is at this URL here. And then finally, you have here a lot of function resources. But basically, what you need is if you go to gslb.ch/XAMUfunctions18, okay, gslb.ch/XAMUfunctions18, this is where you will get the slides, the repositories, and basically everything you need to get started with function and to dive deeper. So that would be the extent of my presentation. Now, if you have questions, it's probably a good time to do that. And I'm going to take a sip of water and wait for questions. But in the meantime, thank you very much for your attention in any case.
Well, thank you so much, Laurent. I'm astonished. Cloud computing without a dedicated server. How cool is that? So thanks, everybody, for being here. And of course, this guest lecture is going to be, or it was recorded, it's going to be posted. You'll be able to access that on our website. That's at university.xamarin.com. And while you're there, don't forget to check out our other offers. We have lightning lectures there. We have, of course, other upcoming guest lectures. So, for example, we'll have Jim Bennett, who Laurent just mentioned, here talking about mobile apps built with F#. We'll have Kent Bogart, who will visit us and teach us a new way of thinking with reactive UI. So stay tuned for more. And as Laurent just said, if you have any questions, bring them along. We're still around trying to answer them.
All right, so I am unmuted now, right? So somebody mentioned the experience was sluggish. I do agree. I think that there was a very bad interaction between GoToMeeting and so between GoToMeeting and basically my machine, right? So I blame my machine. I blame GoToMeeting. If you develop functions application locally in a Visual Studio or anywhere else, basically it's very, very snappy and very fast. The snappiest way to create functions is probably actually Miklos left, so he doesn't hear that, but for everybody else, and yes, GoToMeeting is a resource hog, that is correct. But basically, the experience is very snappy normally, and the snappiest way to do that is to use Visual Studio Code. And so for those of you who don't know Visual Studio Code, it is an absolutely awesome editor. Let me see, it's here. If you want, it's something like a text editor on steroids. Okay, and so it is going to allow you to do all kinds of things. For example, ASP.NET, ASP.NET Core, and you see even Visual Studio Code is actually slow to start here, which shows that really my machine is overloaded right now, and I'm terribly sorry about that. But basically here I have Visual Studio Code open. You can do Git directly from here, and the really cool thing is that you can add tons of extensions. There are really a lot of extensions here, including, I don't have it here, but including an Azure Functions pack. And so using that, you can develop Azure Functions directly from here. You can even deploy them directly from Visual Studio Code. So it's a really fast way to do that. Now, personally, I like Visual Studio, for Windows because of the whole debug experience. It's really awesome, especially the fact that I can really test all my things locally and do that. So again, don't judge Azure Functions by the slugginess of the demo today. It is a lot snappier than it looks and really, really a lot faster, okay?
Yeah, absolutely. I think that's always the best experience. Just go and try things. And by the way, Visual Studio Code has got a dark theme too. We should mention that. So I guess with that, we'll call it a day. And again, thank you, Laurent, for being here today. And I'm sure—
No problem. It was absolutely my pleasure. Sorry.
No, it's just say, I'm pretty sure we'll meet again here at Xamarin University one day. And until then, thanks, everybody. Thanks for joining, and goodbye.
Bye-bye. Thank you.